On June 1, 2009, Air France Flight 447 vanished over the Atlantic Ocean. It was a routine flight from Rio de Janeiro to Paris, but it ended in tragedy. The Airbus A330 carried 228 people. None survived. It became one of aviation's most puzzling disasters. The incident shocked the world. How could a modern aircraft simply disappear? It took nearly 2 years to find the wreckage. The black boxes were recovered from the ocean floor. They held crucial data about the flight's final moments. This tragedy raised many questions. It challenged our understanding of aviation safety. It exposed vulnerabilities in pilot training, and it revealed the dangers of relying too heavily on automated systems. In this essay, we'll explore what happened to Flight 447. We'll look at the weather conditions, technical issues, and human errors. We'll see how this disaster changed aviation, and we'll learn how it's made air travel safer for all of us. Air France Flight 447 took off from Rio de Janeiro on May 31, 2009. It was scheduled to land in Paris the next morning. The flight began normally. The weather was clear, the pilots were experienced. The aircraft was in good condition. The plane climbed to its cruising altitude of 35,000 feet. Everything seemed normal. But as the plane approached the equator, things began to change. The flight was entering an area known for turbulence. As Flight 447 continued north, it entered the Intertropical Convergence Zone. This area is known for its volatile weather. Huge thunderstorms can form quickly here. These storms can reach heights of over 50,000 feet. The pilots could see the storm clouds on their weather radar. They decided to fly through them. This is a common practice. Modern aircraft are designed to handle such conditions. But this storm was particularly severe. Inside the storm, the plane encountered heavy turbulence. Ice crystals began to form on the outside of the aircraft. This is normal in high-altitude storms, but it can cause problems if it affects certain instruments. The passengers likely experienced a bumpy ride, but at this point there was no reason for serious concern. The pilots were dealing with challenging but manageable conditions. However, the worst was yet to come. As the plane flew through the storm, a critical failure occurred. The pitot tubes iced over. These are small probes on the outside of the plane. They measure airspeed. When they iced up, they gave false readings. This led to a cascade of problems. The autopilot disconnected. It couldn't function without accurate airspeed data. Suddenly, the pilots had to fly the plane manually. This was unexpected and stressful. The cockpit filled with confusing alarms. Many instrument readings became unreliable. The pilots were now flying blind in many ways. They had to rely on basic flight principles. But this was difficult in the turbulent, dark conditions. This situation is what pilots train for. But it's rare in modern aviation. The combination of severe weather and instrument failure was overwhelming. The stage was set for a series of critical errors. Section 5. Pilot reactions and mishandling. In the chaos of alarms and unreliable instruments, the pilots had to act fast. Co-pilot Bonin was at the controls. He reacted to the sudden loss of airspeed data, but his response was incorrect. He pulled back on the control stick, causing the plane to climb. Captain Dubois returned to the cockpit, but didn't take control immediately. The co-pilots were struggling to understand what was happening. It was a recipe for disaster. At Section 6, the fatal stall in descent. As Bonin continued to pull back on the stick, the plane's nose pitched up. This caused the aircraft to lose forward speed. Eventually, it entered an aerodynamic stall. This means the wings weren't generating enough lift to keep the plane flying. The stall warning sounded, but the pilots didn't respond correctly. They were confused by the conflicting information. The plane began to descend rapidly. It was falling at nearly 10,000 feet per minute. For over 3 minutes, the plane fell through the night sky. The pilots struggled to regain control, but they never fully understood what was happening. They were fighting against physics and their own misunderstandings. Tragically, the solution was simple. If they had pushed the nose down and increased speed, they could have recovered. But in the stress and confusion of the moment, they didn't take this action. The plane continued its fatal plunge towards the ocean. Section 7. Search and recovery efforts. At 2:14 a.m., Flight 447 hit the Atlantic Ocean. The impact was devastating. The plane broke apart instantly. All 228 people on board were killed. The search began immediately, but the crash site was in a remote part of the ocean. It took 5 days to find the first debris. Bodies and some wreckage were recovered. Finally, in April 2011, the main wreckage was found. The recovery of the black boxes was crucial. These provided vital information about what happened in the final minutes of the flight. Section 8. BEA Investigation Findings. The French Bureau of Inquiry and Analysis for Civil Aviation Safety, or BEA, led the investigation. They analyzed the black box data, wreckage, and other evidence. Their final report was released in July 2012. It provided a detailed account of the crash. The BEA found that the initial problem was the icing of the pitot tubes. This led to inconsistent airspeed readings. But this alone didn't cause the crash. It was the pilot's response to this situation that proved fatal. The report highlighted several issues. The pilots weren't properly trained to handle high-altitude stalls. They didn't follow proper procedures for unreliable airspeed indications. There was poor communication between the pilots, and they failed to recognize and recover from the stall. The investigation also pointed out design issues with the Airbus A330. The stall warning system was confusing, and the flight control system allowed pilots to make extreme maneuvers. These factors contributed to the pilot's confusion and incorrect actions. Section 9. Primary causes of the crash. The BEA identified several primary causes of the crash. First was the temporary inconsistency in airspeed measurements. This was likely due to ice crystals blocking the pitot tubes. It led to the autopilot disconnecting. Second was the inappropriate response of the flight crew. They were startled by the sudden loss of autopilot. Their actions destabilized the flight path. They failed to follow the unreliable airspeed procedure. Third was the crew's failure to diagnose the stall situation. They didn't recognize that the plane had stalled. They never understood the reason for the stall warning. As a result, they didn't apply the correct recovery procedure. Lastly, there was a lack of clear display of the airspeed inconsistencies. The cockpit instruments didn't clearly show the pilots what was wrong. This contributed to their confusion and incorrect actions. Section 10. Aviation Safety Improvements. The AF447 crash led to significant changes in aviation. Airlines improved their pilot training programs. They focused more on handling high-altitude stalls and unreliable instrument readings. Pilots now practice these scenarios regularly in simulators. Aircraft manufacturers made changes too. Airbus modified the pitot tubes on A330s and other models. They are now less likely to ice up. The stall warning systems were improved to be clearer and more consistent. Flight data monitoring systems were enhanced. They now provide better real-time information to airlines. This helps identify potential issues before they become dangerous. It also helps in locating aircraft if they do go missing. The aviation industry also improved its ability to locate crashed aircraft. New systems were developed to track planes over oceans. These include better satellite tracking and underwater locator beacons with longer battery life. Section 11. Reflecting on air travel safety. The Air France Flight 447 disaster was a wake-up call for the aviation industry. It showed that even with modern technology, things can go wrong. It highlighted the importance of pilot training and clear communication. Today, air travel is safer because of lessons learned from this tragedy. Pilots are better prepared for unusual situations. Aircraft are more resilient to extreme weather. And tracking systems make it easier to find planes in trouble. But the AF447 crash also reminds us that flying is complex. It requires constant vigilance and improvement. As technology advances, new challenges arise. The aviation industry must stay alert and adaptive. For passengers, this tragedy underscores the importance of safety measures. When flight attendants give safety instructions, it's crucial to pay attention. In the rare event of an emergency, this knowledge could save lives. Air travel remains one of the safest forms of transportation, but it requires the ongoing efforts of everyone involved to keep it that way.